So in the previous part of this lesson here, we took a look at what happens if all of a sudden we get information for a triangle which does not work. Okay, so in the case that we had here, we were given this side length here, and based on the other information that we had, this does not work. Therefore, we have a triangle that in fact is not true. Now, we're going to have another case here where we can use sine law, where we can get two different triangles using the exact same information. Okay, actually, without using sine law, we'll use sine law to kind of get some answers, but the basis is not in sine law here. The basis is that we can get two different triangles that have the same side lengths and angles, but are actually different triangles. Okay, and how we get that is exactly as follows. Let's draw a triangle with our following criteria, and we're going to actually draw two of them, and I'll show you why we draw two of them. So the first one here, we have angle A is 30, B is 7, B is 12, and A is 7. Now you'll notice that the angle A and the side B are the same as we had earlier. It's just that side A now, we have a number bigger than 6. Okay, so we know it actually works. Remember, if it's less than 6, it doesn't work, such as the 4. But if it's bigger than 6, this will in fact work, and we can use this. So let's label this triangle here. Okay, we're going to start with angle A is going to be here, and that's going to be 30 degrees. There we go. Okay, so there's that. Let's try something here. Okay, so that's 30 degrees. We have side B right here, which is 12 centimeters. And across from A is going to be side A, which is going to equal 7 centimeters. Okay, it's going to be 7 centimeters. Now, to draw, we're not given side A, we're not shown side A, but we can draw it out, and it's 7 degrees, meaning that, so let's just remember that, try this again here. This right here, okay, so I'm just going to draw it out of there. This one right here was 6 centimeters. Okay, so 7 centimeters is going to have to go farther like that. And so what we're going to do is we're actually going to put it like that. That's going to be a 7 centimeter long one. And so we can then calculate angle B using sine law. Now I'm going to quickly just put in sine law. I'm just going to write that in on top here. Make our formula. Okay, because we're going to use it again. So instead of writing it out multiple times, I'm just going to write it out once over side B. It's really all we need. I'll do the third part as well. We're not going to use C at all. We're just going to use A and B. So to find angle B, what we're going to do here is we're going to plug in the information that we know. We know angle A, we know side A, and we know side B. So we're going to have sine of 30 degrees over, let's see, that was 7 centimeters. And we have sine of big B over 12 centimeters. Okay, cross, multiply, and divide, which is what we always do. And quickly do a little calculator here. So we have 12 times sine 30 divided by 7. And we do inverse sine of our answer, and we get 58.997 or 59 degrees. So we're just going to call that 59 degrees. There we go. Okay, so B is 59 degrees. And we're going to call it pretty exact. It was pretty darn close in our measurement. So this angle right here is 59 degrees. And that makes about sense. Okay, it's less than 90. This is looks like an acute. Oh, it'd be actually just an obtuse triangle. This would be 91 degrees here if we do all of our measurements as well. Okay, so there we go. That is looking at the first this first one here. Now the thing is that we're given this information. We can actually make a second triangle. Okay, we can make a second triangle using the exact same information. Okay, and I'm going to draw it out here. Okay, so we have A, and A was 30 degrees. All right, my typing program is having some fun with me here. Okay, so A is 30 degrees. And at the same time as before, B is 12 centimeters. And we're going to make A be, or we're told that A is equal to 7 centimeters. We want to try to find out angle B. Now, you'll notice here, we took this line and we moved it down to the right in this first case here, but we can actually do something different. We could move the same line could go right there. That line there is also 7 centimeters. Okay, we can either move it out or we can move it in. It actually gives us a different triangle. You'll notice these two triangles are different. This angle right here is different from this angle over here. Okay, they're different, meaning that this triangle is a different triangle. Even though it has 3 pieces that are exactly the same, it's different. So let's solve for angle B. Let's use a different color here. Okay, angle B, right here. Well, let's put it into sine law. Okay, we have a, little b, and we want to try to find big B. So let's do sine of A over little a, which is 7 centimeters, and that equals sine of B over little b, which is 12 centimeters. And we can solve for B. I'm not going to bore you by going into the calculator, but you might see that this first one and this second one are exactly the same. So what do you think B is going to be? 59 degrees. Okay, if we put this into the calculator, we're going to get that angle B right up here is 59 degrees. Okay. Does that look like 59 degrees? Nope. You should be able to see that that's not 59 degrees. Okay, 59 degrees is a small acute angle. This is definitely not a small acute angle. Okay, if we wanted to make 59 degrees, we would have to take this line. See if I can get this line here. Oh, I'll move B down a little bit. That might help. Okay, we'd have to move this over here, and I can't move it right now, but that's okay. Okay, we have to move it. This line, this angle here is not 59 degrees. This one over here is. Okay, that angle is 59 degrees. This angle is not. This angle right here is going to be the supplementary angle to 100 or to 58 degrees, 59 degrees. So we do 180 minus 59 degrees. And if we do some quick mental math, that's going to give us 121 degrees. Okay, so this angle inside here is 121 degrees. So we have to be careful when we are doing these types of problems. Okay. Why could there be 2 solutions? And I'm just going to go over this really quickly here at the end of this video. Okay, given an acute angle, okay, where A is greater than what we kind of said before, so side A is shorter than side B. Yeah, so if we have these cases here, we could have 2 different triangles. Okay, you can imagine A swinging like a pendulum, creating 2 possibilities. Okay, the first one here, we have this one, A going out. The second one, A comes in. The first one, A is definitely acute. Okay, 59 degrees was. The second one, B is definitely obtuse, 121 degrees, which we saw earlier. Okay, so it's very specific, and we understand that there are 2 different solutions to this case. And we have to be very careful about that, as when we solve, we need to know what those two solutions are. Okay. So there are two possible solutions. We could have a triangle like this. We could have a triangle that looks like this. They are different, okay, even though they have the same three piece of information, and sine law is going to give us the same angle, but it is in fact different. Okay, so that's something we have to really be careful for.